Dmitri Mendeleev. So we have some important vocab words at the top of our slide. Atomic mass is the first one, total number of protons and neutrons in the nucleus of an atom. We did review in class today that in our periodic table is organized by atomic number. And so let's remind ourselves here, when we're looking at an element, hydrogen, for example, our atomic number is 1, right? That's the number that's usually at the top of the element. The symbol is the 1 or 2 letter abbreviation for the name of the element. And in this case, it's hydrogen. Okay, when we're moving along, atomic mass will be here at the bottom. That's what we were reading here. That's the total number of protons and neutrons. Periodic table. This is a table that organizes the elements based on their atomic number. So that small number at the top of the element. The group is a family of elements going down the periodic table, and a period is a family of elements going across. And we did look at that today as well. Okay, periods, rows going across. There's 7 of them. See, they're listed 1 through 7 here, and they're going across the periodic table. Then if we're talking about groups or families, there are 18 of them going up and down. You see the numbers 1 to 18 here. Okay, so that's a little bit of a review. Dmitri Mendeleev. Scientists have been studying elements for many years. In 1869, 63 elements had been discovered. Most of the elements were solid metals, but there were some liquids and a few gases. Dmitri Mendeleev was a Russian scientist who began studying elements during this time period. As Mendeleev was studying the elements, he began to notice that they had certain characteristics in common with one another. Mendeleev began examining these similarities to see if there was a pattern. Like a true scientist, Mendeleev began recording data about each element. He started to record the melting point, the density, the color, and the atomic mass. The atomic mass is the total number of protons and neutrons. So see how important that is that they've repeated it again from the top. So when he was studying Mendeleev, he noticed, look at the periodic table. These elements have a lot of things in common. Let me record these things that they have and see how I can organize it. Okay. Each of these recordings, moving to slide 2, were written on a card, and Dmitri began to organize them into a pattern. While organizing them based upon their properties, Mendeleev noticed that in his arrangements, the elements were being organized in order by their atomic mass, right? So when he was putting them in the order here that we now know today, there weren't as many when he was alive, but he began to realize there was a pattern. Atomic mass, right? That's the number at the bottom of it, right? So if we're looking at this here, to the atomic mass here, right? The protons and neutrons, they helped him figure it out that they are going in that order. Arranging them by their atomic mass, he also noticed that the elements shared the same properties. He grouped these elements together and began to notice a pattern among the mass and the properties the elements shared. So what properties, question, did Mendeleev record to organize the elements? So there's a few answers that we're looking for. So we're looking for about 4 answers, really, right? And I believe it starts on this last page. So what did he use? What did he record? So he recorded, look here, he started to record the melting point, density, color, and atomic mass. Those are the 4 answers we're looking for our point here, right? So we're looking for 4 answers on this one, okay? The periodic table. In 1869, Mendeleev created the first periodic table of elements. The word periodic means a regular, repeated pattern. The periodic table is the table that organizes the elements based on their shared properties. As time went on and more scientists began studying elements, the original periodic table was tweaked as more information was learned. So basically, as they learned about more and more of these elements, they did have to make some minor changes, some tweaks as they're putting it, but nothing too big. When organizing the table, Mendeleev left blank spaces in it, right? So when he was organizing it, he's like, okay, I'm using these patterns, but nothing should be in this spot. I'm going to leave it empty, and he skipped some. So based on his organization of the elements, he predicted that there were elements on Earth that had not yet been discovered. As new elements were discovered, scientists were able to fit them into the blank spaces on the table. Scientists were able to predict how the element would react because of what they already knew about the periodic table. So isn't that interesting? So he could look and see, there's no element in this spot, but I bet you when we do discover it, it will be able to do this, this, and this, right? Because he realized that there was a pattern to them. Today, scientists have realized that the periodic table is organized by an element's atomic number. The atomic number is the number of protons in the nucleus. So we have made a change into the modern periodic table is what we know. They used to organize it according to atomic mass. Now, it's a big difference. Now we organize it according to atomic number. Modern periodic tables are organized in this fashion. The atomic number determines chemical properties of an element, right? So that's some important information there and a difference between the old one was mass, but what we now study is atomic number. So how did Mendeleev help other scientists who were studying the periodic table? How did he help them? Well, he left remember what he left? Some blank spaces, right? Because he realized, there's some elements that haven't been discovered. So he left some blank spaces. So you should be writing in your response there. He did leave those blank spaces. Our next question, how has the periodic table changed over time? So we talked about that, right? There were some changes. It used to be organized by atomic number. Mass. Now it is organized by atomic number, right? So it is now organized by atomic number, right? This is how we now organize it in the best possible way for us, okay? So what have we learned today in our reading? That Dmitri Mendeleev was the first scientist to organize the periodic table of elements, and the periodic table that organizes elements by their atomic number. That's how we do it now in our modern time. So we have 3 questions here, okay? How is the modern periodic table organized? So what we do now is it atomic number, atomic mass, or AMU? How did Dmitri Mendeleev organize the periodic table? Atomic number, atomic mass, or by AMU? So remember, we organize it by atomic number. He used to organize it by atomic mass, right? So those are the answers you're looking for here. How is the periodic table useful? Well, let's think about it, right? Scientists, right? Mendeleev left spaces because now we can understand. He realized, Mendeleev, that he left those spaces because we had elements we hadn't yet discovered. So how is it useful to us? Well, if there's a blank space somewhere, then we realize we haven't discovered a certain element, right? So scientists realize what has not yet been discovered. Or you can even say that they can see some similar properties, right? So remember some of them that were left empty. Oops, have some misspelling there. Some of those that were left empty, he realized, and they had these. There should be something here that's similar to this element. So I'm going to leave it blank. And there you go. Okay, so please make sure when you go back to your own copy, you are responding to all of your questions. This one was done for you. This one you do have to answer on slide 2, on slide 3, slide 4, right? And then answering these questions on slide 5. Put the letter of the answer here, A, B, or C. Again, A, B, or C, and then filling in your answers on this one. Let me know if you have any questions.